I claim here's one way to understand the Cantor set. So let me just summarize some of the things we've just noted. C is closed. Why is it closed? It is the what? Oh, sorry, no, why is these dots closed? Because it's the intersection of arbitrarily many closed sets, right? Because it's the intersection of closed sets, right? Okay, great. We see that. Here's another fact about C. C is, in fact, has a property that the book calls perfect. A perfect set. What is a perfect set? Perfect set means it's closed and, anybody know? Every point is a limit point of C. Every point of C is a limit point of C. Okay, so what does that mean? Any point here can be approached by other points. No point is isolated. Yes? By the way, can you think of any of other perfect sets besides this one? How about the closed interval? Every point is a limit point. Yes? And it's closed. All of R is a perfect set. Okay, so lots of perfect sets, but this one's interesting because it's perfect, and in fact, it has no interior, which we'll come to in a bit. Okay, but I haven't justified why every point is a limit point. But I claim this follows from the following insight, which is perhaps the best way to think about a Cantor set. I claim that C consists of real numbers that have a certain property. When you write the real number in ternary, right, not decimal, not binary, but in ternary expansion, then it only will have zeros or twos in its ternary expansion. So whose ternary expansion contains, I heard that, I'm coming, contains only zeros or twos. So let's do several examples, including Bonnie's example, 1/3. Oh, it wasn't Bonnie? Oh, it was Jenny. Oh, okay. Well, we'll still do it. Okay, so check this out. By the way, what does ternary expansion means? It means divide into, instead of powers of 10, divide using powers of 3, right? So if I, in ternary, in binary you only use 2 digits, 0 or 1. In decimal you use how many digits? 10, 0 through 9. In ternary you use 0 through 2, okay? Would you agree that all the points in this interval, we'll get to 1/3 in a second, begin with 0? In other words, there's 0 over 1/3 plus, so ternary would just write things in powers of 1/3, 1/9, 1/27, sorry, 1/3, 1/9, 1/27, etc. Okay? And I claim all the things in this interval begin with 0 in their expansion, except possibly its endpoint, but I'll come to that in a second. Yes? Then these begin with a 1 over times 1/3. And these begin with a 2, because they're 2/3 plus something, right? Similarly, for the second decimal ternary place, this would correspond with 0. This correspond with 1. This would correspond with 2, yes? 0, 1, 2, 0, 1, 2. Are you with me? Okay. And so if I want a point, let's say in here, I claim that all the points in here begin with the ternary expansion 0.022. All these points in here begin with 0.022, ... which there might be something else, right? You with me? Okay. So ternary looks something like this. Cantor set's one of the coolest things, I just have to say. So let me just write ternary. So ternary would be something like this. Write everything in powers of 3. So for decimals, for these such things, it might be, you know, it's a sum of AK, 3 to the k, where k could go from any integer, minus infinity to infinity. And so we write this as, you know, something like this, a0 dot a minus 1, a minus 2, ... and then the other digits go the other way. Here, this is the expansion. Okay, goes both ways, but we're only looking at going this way. Okay. Now, what about 1/3? I claim 1/3 can also be written in ternary with only 0s or 2s in expansion. Do you both buy that? Yes? Tell me how, Julian. Oh, sorry. Oh, who said yes? Willie. Excellent. Yeah, so even 1/3 is point, you can see this here. It's 0, 2, 2, 2, ... with a bar over it. Okay. Just like in decimal, 0.9999999 is really also the same as 1. Okay. These representations are not unique because 1/3 could be written like this, but it could also be written 0.10000, ... Okay? With me? Now, the only ones in decimal that are not unique are the ones that end in all 0s or all 9s, right? Because one could be turned into the other, right? The only ones in ternary that are not unique are the ones that end in a string of 2s or 0s, right? If you want to change 2s into 0s, you increase this to a 1, but then, of course, that violates the rule. So really what I'm saying here is you can always write them. You can write, has an expansion that contains only 0s or 2s. Yeah, I won't change that, but which has a ternary expansion containing only 0s or 2s. Okay, great. Now, what does this mean? Well, I claim this means that you can see the answer to the question. How many points are there in the counter set? Uncountably many. Why? Yes, it's exactly the same argument. Cantor's diagonalization argument would work here. So this shows us, if you see that this is true, what this shows us is not only does it show that every point is a limit point, it shows that C is uncountable. So it also shows that C has non-endpoints of non-endpoints of Kn points. Right? For instance, what's a point here that's not an endpoint? Dylan? Well, I actually don't know what 1/4 is off bat in ternary, but okay, 0, 2, 0, 2, 0, 2, ... Would you agree this is never an endpoint? What are the only endpoints? The endpoints are the ones that actually they either end in they end in all 2s, don't they? Right? Right? Or a string of what? Well, if they end in a string of 0s, then there's a 1 preceding, and or a 0. I guess a 0. That's right. Yeah, it could be all 0. Or it's 0.